This is assigning oxidation numbers worksheet and walkthrough. And this is page 104 in your notes book. All right, so let's get started. You're going to need your periodic table and you're going to need a little bit of math skills. All right, so periodic table is what you're going to need, right? Because we need to know the oxidation states of some of our common elements. So remembering from your periodic table, group 1 plus 1, group 2 plus 2. So I'm just going to jot those down up here at the top, some of our rules. Group 1 plus 1, group 2 plus 2, oxygen -2. Let's see, what are some of our other rules? Our halogens, they're going to be -1 if they're at the end of a formula. If they're in the middle of the formula, we've got to do some math. And we want the sum, right, which means you add, the sum of the oxidation numbers of your oxidation states, right, oxidation numbers must equal 0. And the sum is equal to the polyatomic charge. So I'm just going to write poly charge if we have a polyatomic ion. So within a polyatomic ion, the sum of the oxidation numbers can be add up to the charge of the polyatomic ion, which we're going to need table E for. All right, so let's just jump in and let's get started with number 1, right? So we have HCl, that's hydrochloric acid. Let me just leave that stuff up there at the top. So the way that I do this is I take the oxidation states that I know from my periodic table or from the rules that we have in our notes, and I write them right on top of this number. So I have a +1 because hydrogen's in group 1. So +1 has to add up to 0 with the chlorine. So what number plus +1 equals 0? I need something to cancel out a +1. And in this case, chlorine will be -1. So when you're writing this down, so hydrogen is equal to +1 and our chlorine is equal to -1. I know that looks like a +7, but maybe I'll do that so it looks more like a 1. All right, let's go on down to number 2. First, I want to go to my periodic table and there's 2 ways to approach this, potassium nitrate. You can do potassium plus nitrogen plus oxygen is equal to 0. And that's the way that I'm going to do this one. Or you can do potassium by itself, and then the nitrogen and the oxygen have to add up to the charge of the polyatomic ion. So since this is relatively straightforward, I'm going to do the sum of the oxidation states of this whole compound has to equal 0. And so I need to go with my rules, and I need to look at these elements on the periodic table. So on the periodic table, potassium has a +1 charge. Everything in group 1 is always +1. So I'm just going to do K is equal to +1. So now I go to nitrogen on my periodic table. Nitrogen's got like a whole long list of oxidation states, right? You should have your periodic table open so that you can look at these while I'm going through them. And so I do have a rule of oxygen being -2. I'm just going to jot that down over here. So my oxygen is -2. Every single oxygen, however, is -2. I have 3 oxygens that are -2. So my total charge for oxygen is -6, right? 3 times -2. I already have a +1 from that potassium. So then I need to cancel out that -6. So when I cancel out that -6, I need that nitrogen to be a +5, right? Because a +5 and a +1 is +6. The -6 equals 0. So then my nitrogen in this case is a +5. So when we wrote formulas at the beginning of the year, we would just use the first negative charge for our nonmetals. But since once those nonmetals are in the middle of a compound, right, like that nitrogen, we're going to have to use some math to figure out that charge by using the known charges that surround it. So now in number 3, this is our hydroxide, right? Which is, remember, this is our base ion, right? Hydroxide on table E, and you'll see that there's a negative charge. So this means that that oxygen plus that hydrogen has to add up to a -1, not 0 in this case, because this is a polyatomic ion. So I go with my rules. I go for my rule for oxygen is oxygen being -2. And I go to my rule and hydrogen being in group 1 and hydrogen is plus 1. And so if I have a 1 positive 1 and 1 negative 2, when I add those together, that equals a negative 1. So we're done with that one. Let me just scroll down over here. Oops, you want me to pull that up? All right. Actually, let's go down to here. Let's look at number 4. Oh, too far. I always just take it just one step too far. All right, so let's look over here at number 4. I'm going to find my elements on the periodic table first and foremost. And so my magnesium is a positive 2 on my periodic table because it's in group 2. And group 2 is always plus 2. And so now I can use my nitrogen on the periodic table. If I look at it, there's a whole bunch of charges, right? But since it's at the end, it's likely to be the first one. So it should be -3, but let's just see if that makes sense, right? So remember, the sum of the oxidation states has to equal 0. So if I have 3 positive 2s, right? So each magnesium is a positive 2. So that's the oxidation state of magnesium. So I have 3 times positive 2. So my magnesium is a total charge of positive 6. My nitrogen, to cancel that out, has to total up to a -6. So, but I have 2 nitrogens. So 2 times 3 is -3 is going to be my -6. So then each of these nitrogens is a -3. So nitrogen is equal to -3, which matches the first negative charge on the periodic table. But remember, that usually only works when you have the nonmetal as the last element listed in a formula. So now if I look here, now I have a polyatomic ion. So I can either do the charge of potassium and then chlorine and oxygen added up to the charge of the polyatomic ion, or I can do the whole thing and the sum of the oxidation states equals to 0. So the sum of the oxidation states equals to 0 is my preferred way to do it. It's not wrong to do it the other way. I'm going to do the other way with question number 6. So I look on my periodic table because I want to find the charges that I know for sure. Potassium is in group 1, so that means that potassium is a positive 1, right? So then, so far, I have a positive 1 charge. I go to my periodic table. Chlorine's got a whole list of charges, and it's in the center. This means that I have to use the charges on either side to figure out the charge of that chlorine. I cannot just assume it's going to be the -1. It will not be -1. So I have oxygen. I know oxygen is -2. So how many oxygens are there? Every oxygen is -2. So that means I have 3 times -2. So that means that my oxygen has a total charge of -6. So I have a positive 1 already. And so what's missing now is I have a positive 1 plus what number equals, plus the -6 equals 0. Well, I need a positive 6 to balance out a -6, and I already have a +1. So then in this case, my chlorine is going to be a positive 5, because I have a positive 5 plus a positive 1 is positive 6, then 3 -2s is equal to the -6. Right, now let's examine this aluminum nitrate. So in this case, I am going to go and I'm going to use my polyatomic ions to figure this all out. I go to the periodic table and I go and I look at aluminum. Aluminum only has 1 charge listed on the periodic table. So it's pretty safe to assume that the aluminum is going to be that charge. But let's also go by the polyatomic ion. So if I go to table E and I find this polyatomic ion on table E, this whole polyatomic ion, right? So I'm just going to write that over here. This whole thing is equal to a -1. I have 3 of those. If I have 3 -1 nitrates, then this aluminum has to be a positive 3. So that confirms what I see on the periodic table as aluminum's charge as positive 3. But now I need the charge of nitrogen and I need the charge of oxygen. So now this nitrogen and 3 oxygens has to add up to the charge on the polyatomic ion, which is -1, which again, you can get the charge of the polyatomic ion from table E of your reference tables. So now let's go through. Now I know I'm going to have to figure out this nitrogen, and I'm going to go with the oxygen charge is -2 periodic table says oxygen's -2, and you're pretty safe to do that. There's very few exceptions. There's maybe 2 exceptions, and I'm just going to give you a clue for oxygen being -2. Here's 2 exceptions to that right here. But don't worry about the exceptions. Focus on the rules that you know. You're not likely to be asked too much about the exceptions. So then now I have oxygen being -2. Okay, so I have 3 -2s. So my total charge for oxygen is -6. My total charge with the nitrogen has to equal -1. So my nitrogen, therefore, must be a +5, because a +5 with a -6 will add up to -1. So nitrogen is a +5. All right, so now let's look at number 7. And one of the rules that I forgot to mention above when I was writing my rules for oxidation states is an element that is uncombined. So uncombined. This is the element sulfur. Even though there's 8 sulfurs stuck together, it is still the element sulfur, because you have to have 2 or more different elements in order to make a compound. So this is just an element. So this is an element, and all elements have an oxidation state equal to 0. So that is the oxidation state of the nitrogen. Or sorry, not nitrogen, the sulfur. All right, so let me just go scroll down here. All right, so here we have, here we have our hydrogen and oxygen. I said this was going to be an exception to oxygen being negative. Hydrogen and oxygen, if I look at electronegativity, right, our electronegativity is going to be higher for oxygen. So higher for oxygen. And then therefore, it's going to be negative. So then means my hydrogen has to be positive. And so I go to the periodic table. Hydrogen's in group 1. All right, so hydrogen in group 1, and I know it has to be positive because it has the lower electronegativity. So that means that my hydrogen will be equal to +1. So now if my hydrogen is equal to +1, and I have 2 positive ones, that means that +2 total charge for the hydrogen. So now I know that that has to add up to 0. So then those 2 oxygens have to add up to -2. I have 2 oxygens that have to add up to -2. So then in this case, the oxygen will be -1. And this is called a peroxide. So this is a peroxide. That's hydrogen peroxide. You're familiar with that molecule. The only other time I've ever seen this is sodium peroxide. But then in this case, you can use the sodium being +1 because it's in group 1, and then group 1 is always +1. All right, I'm going to throw in a little bit of review. Let's just also talk about how do we name this compound, because that's also figuring out oxidation states. So I need to figure out the oxidation state of lead, and I need to have the oxidation state of oxygen. So I'm going to go to the periodic table, and I see my oxygen is -2, right? So -2. And if I have 2 of those -2s, that means the total charge of those 2 oxygens is -4. So then that means that the lead plus the oxygen, the sum of the oxidation states has to equal 0. So that means that this lead must be equal to +4. So then that's the oxidation state of my lead. So when I name this, right, the metal, guess its whole name, lead. Because lead is a transition metal and it has more than one oxidation state, it needs a Roman numeral that indicates, and the Roman numeral tells you the charge. So since I figured out the charge is +4, that means that Roman numeral 4, and then I change the oxygen to oxide. Right, so then that's lead 4 oxide. All right, let's keep moving on with these oxidation states. All right, so I've got sodium, hydrogen, sulfur, and oxygen. Oh my goodness, there's so many. Sodium, hydrogen, sulfur, oxygen. We need to figure out. All right, so going to my periodic table is always my first step, right? Want to get my known charges down. Sodium is in group 1, so I've got a +1 charge, right? So sodium is +1. Hydrogen is going to be +1 or -1. So let's hold off on that for a bit. Oxygen -2, right? -2. How many oxygens are there? Every oxygen has a -2 charge. There's 4 oxygens. Remember, this whole thing has to add up to 0. I have 4 -2 oxygens, so my oxygen charge total is -8. And I have a +1 with that 1 sodium. Now I have 1 hydrogen and 1 sulfur. All right, so then my hydrogen is also going to be a +1, because remember, I have to cancel out a +8. All right, so my hydrogen will be +1. All right, so now I got to figure out the sulfur. So now with the sodium and the hydrogen, I have a total charge of +2, and I got to cancel out a +8. So what am I missing? I'm missing a +6. So that is the charge of my sulfur. And again, you could do this in a couple different ways, right? You can do the sodium being +1, and then you can do the hydrogen sulfate adding up to -1, the hydrogen, sulfur, and oxygen adding up to -1, right? You can do that with the polyatomic ion as well. All right, let's go up to the top of our next column, and we'll just keep going with these, shall we? We're on a roll. All right, so let's see here. I have sulfurous acid here, and I need the oxidation state of hydrogen, oxidation state of sulfur, and oxidation state of oxygen. Go into my periodic table, and I want to go with my known charges. So I know that since this is an acid, I know it's an acid because it's on table K of my reference tables, and I have the hydrogen as the only positive ion, right? So then there's my +1 for the hydrogen, my H+, which makes an acid an acid. And so if that hydrogen is a +1, I have 2 +1s. So that's a total charge of +2 from the hydrogen. Now I go to my periodic table, and I know my oxygen being -2. So if I have a -2 for this oxygen, I have 3 -2 oxygens. So 3 times -2 is -6 total charge for those oxygens. So my hydrogen and sulfur have to cancel out that -6 oxygen. I already have a +2. So the missing amount of charge is going to be a +4 for that sulfur, because I have a +4 plus a +1 and a +1, and then that balances out that -6. All right, so now here I have sulfuric acid. Again, I know I have an acid because I have an H+, and again, this is also listed on table K. So now we can do this a couple different ways, right? We can do the hydrogen, and we can do the SO4 as a polyatomic ion. So let's do that one. So we have hydrogen, sulfur, and oxygen. So if I'm going to go with my polyatomic ion way, right, that means that my sulfate is SO4, and that has a charge of -2. That's why I needed 2 hydrogens to balance it out. So my hydrogen is still +1. Okay, so I have 2 +1s, maybe look that more like a 1. So I have 2 +1s. That cancels out this sulfate being -2. So now my 4 oxygens, right? Oxygen charge is -2, right? I'm going to use the periodic table. And if I have 4 -2 charges, that means my oxygen total charge is -8. So this sulfur has to add to -8 to equal a -2, right? So then I could use X's and whatever, and I could set it up like algebra, or let's play around with numbers. What number do I keep adding to add up to -2? Then my missing value here is going to be a +6, right? So a +6 and a -8 adds up to a -2. So then in this case, my sulfur is a +6. Okay, let me just go scroll down a little bit here. So now let's look here at this barium oxide. So I need the charge for barium and oxygen. Let's take a look at our periodic table. Remember, you should have your periodic table next to you so that you can look and confirm that I am saying, the right things. I have them in my brain because I've been doing chemistry a long time, but you're going to need to look at your periodic table. All right, so I know my oxygen is -2, and I see that my barium, hold on, let me just erase that for a second. Where's the eraser? There we go. Let me just erase that for a second. I don't know, eraser is just kind of a garbage on this Cami. All right, barium's in group number 2. So group number 2, oops, let me get my drawing here. Group number 2, barium is a +2. All right, so this is a little bit weird. So this is why I erased the oxygen, right? Barium is, remember, because oxygen does have, this is going to be one of our exceptions. But I do know that barium is +2 because barium is definitely in group number 2. And so can only be +2. So barium is +2. Barium plus oxygen has to add up to 0. Right, I still know that oxygen is definitely going to be negative, but this 2 oxygens has to add up to -2 to cancel out. So each oxygen therefore must be a -1. All right, so remember, there's only a very few exceptions to oxygen being -2. So, but you have to be aware of them. But for the most part, you'll be safe with most questions, especially on the Regents exam with oxygen being -2, unless they're really being mean. Okay, so now let's look over here at this potassium permanganate. And how did I name that? Well, I named potassium, and then I looked up on table E for the rest, and that is the permanganate ion. So now that means my potassium and my manganese, oops, not Mg, sorry, scribble that out. My manganese and my oxygen have to add up to 0. Going to my periodic table, I have my potassiums in group number 1, so potassium can only be +1. My manganese has more than 1 charge. And so my oxygen has the -2 charge. So then here's 4 -2s, right? So our oxygen's -2. So I have 4 -2s. So that means my total oxygen charge, my total negative charge over here is a -8. And I already know that I have a +1 for that potassium. So now what is missing that this 1 manganese has to be to cancel out the -8? Because remember, this whole thing has to add up to 0. So that means that this manganese must be a +7, because a +7 and a +1 is +8 and a -8. So our manganese in this case is a +7. All right, let's go to lithium hydride. So in this case, that means that my lithium and hydrogen, these 2 charges need to add up to 0. Looking at the periodic table, notice how hydrogen is listed second here, right? We have to have a positive, we have to have a negative. Lithium is in group 1. Group 1 is always a +1, right? So lithium is a +1. Oops, terrible handwriting, +1. So that means that this hydrogen is -1. This is -1. And remember, most often the negative ion is listed second and the positive ion is listed first. Remember, and hydrogen can be +1 or -1. And if it's listed in the front, that's usually going to be the +1. And if it's listed in the second, because this is a hydride. Now let's go here and let's take a look at this one here. So I have manganese, which has lots of charges listed on the periodic table, and I have oxygen. So these 2, my manganese and my oxygen, have to add up to a neutral charge. All right, so have to add up to 0. I'm going to go with my known. You have to have at least one element that's a known oxidation state. So my oxygen is going to be a -2. And so I have 2 -2s. So my total charge for oxygen is -4. So that means this manganese must cancel out a -4, and then that manganese is going to be a +4. So then that's a +4. And let's give this a name just to review our naming. Manganese, a little delay in my writing here, manganese. It's a transition metal with more than 1 charge, so it gets a Roman numeral. The Roman numeral is the charge of the manganese. So then that's going to be Roman numeral 4, and then oxide, O-X-I-D-E. All right, let's look at number 17. All right, we're getting there on these. All right, so we only have a couple more. Oops, let me go down here. All right, 4 more, let's go. So here I have oxygen and fluorine. Notice how the oxygen's listed first. Notice in all of our other examples, oxygen is listed second or third or fourth, for example, right? Because generally we go from the least electronegative to the most electronegative. So now I go to my rules, and my rule is fluorine. Remember, there are a few exceptions to oxygen being -2. So this is going to be one of those exceptions because fluorine can only be -1. It is the most electronegative element, so it has to be negative. So if I have fluorine being equal to -1, and that means that my oxygen cannot be -2 in this case, because I can't have an overall charge molecule here of an overall negative charge, because it has to be total charge has to add up to 0. So I have 2 -1s, so my total negative charge is -2 from those fluorines. So then this case, oxygen's also listed first. That's going to give me a clue that oxygen is going to be a positive oxidation state. And so then oxygen is going to equal a +2. All right, so again, an exception. Now let's go on to number 18. I look at sulfur on the periodic table. There's more than one charge listed on the periodic table. So that means I have to know the oxygen charge. So then that means that my sulfur is the one I'm going to definitely need to figure out using a little bit of math. And then my oxygen, I can use that -2 charge from the periodic table. So I'm going to write that over here. So oxygen is -2. The sum of the oxidation states has to equal 0. I have 3 -2 charges, so the total negative charge is -6. So then I need sulfur to cancel out a -6, so therefore sulfur must be a +6. So our sulfur charge is +6. All right, so 19 ammonia, and I know this is a base because it's listed on, I'm just going to jot that down just for fun. This is a base, and I know it's a base. Why? Because table L in my reference tables says it's a base. All right, this is a little bit of weird. This is the one exception to the first element being written as the positive oxidation state. So remember, the positive oxidation state is going to be the least electronegative. The negative oxidation state is going to be the higher electronegative, which again, you have those values on table S to help you. So nitrogen has a higher electronegativity. So that means that my nitrogen is going to be negative. And then that means that the hydrogen will have to be positive. All right, so now let's go to our periodic table. And I know that hydrogen has to be positive. Hydrogen can only be +1 or -1. So then that means that this is going to be a +1. So +1. I have 3 positive ones, right? Remember, the sum of the oxidation states is equal to 0. 3 positive ones means that my total charge is +3 from those 3 hydrogens, right? Hydrogen being +1. So then this means that my nitrogen must be the total negative charge to cancel out that positive charge. So then this is going to be a -3. All right, last one. I just have one capital letter. That means this is just the element sodium. And it's not combined, so it's uncombined. Uncombined. There we go. There's my spelling. It is uncombined. So the oxidation state in this case is going to be equal to 0. No electrons lost, no electrons gained. All right. Thank you for doing all of these oxidation state questions with me. The more you practice them, the better you become. Thank you for watching.